Good morning. Today we are going to see about implementation of insertion sort using C program. So we start our programming by declaring a header file stdio.h. Then we need to have a main program. So every program must have a main program. Within the main function, we will be declaring the required variables. Let's say that first I need to declare the variable size that helps us to get the input for my number of elements to be in array. Now I'm going to give a prompt message to display to enter the size of array. So how many element I'm going to get it? For that I'm going to get it through an input variable called size. So for getting an input we should use scanf statement. My size is declared as an integer, so you should use percentage %d for specifying it is of integer data type. Allocate a memory, get the data and store in this variable size. Now after that we need to declare an array A of size as per our input. Now we need to get the input for your entire array. So printf enter array elements. I'm going to get it one by one. If I have n number of elements, then I have to get n number of array element. For that I'm going to use a for loop for int I equal to 0. If you are going to use an array, first element will be stored from 0th position until your last element. So the last element will be at n minus 1 position, that is like I less than n minus 1 I plus plus. Within this thing you should get an input for your array element. So you should use a scanf statement. My array is declared as an integer collection, so I'm going to use percentage symbol and then allocate a memory using address operator. Store that in an array at a particular index position called as I. So this is how your array elements get from your keyboard, right? So first thing, we have declared our array size, and then we have declared our array size, and then we got all the elements one by one through an loop. Then after that we try to print a sorted data. Let's say that before sorting we will try to print unsorted data informations one by one. For that I'm going to create another function called as a print array function. So print array, for that print array function I'm going to use two parameters. First parameter is my input array, and second one is like number of elements that has was in array, that is like size of your array. So I have passed it. Now we have to define this function print array. Print array is a user defined function that I am going to write at. So you can define this function immediately after your header file. So how to define it? First you should define it with your return type. Print array function does not return any value, so you can write it as void, then give the name of your function print array, then define the parameters. So I'm going to get an array of integers, int a of array. Then I'm going to get the number of elements in the array through a variable called size. Got it? Now we're going to print it one by one. So for printing the array element, I will be using a for loop. The for loop I'm going to index all the position with the help of an I. My first element will be at 0th position, and my last position will be at I less than n position. I less than n position. Here I have defined it with the help of a variable called size. I have defined the variable with the help of a variable called size. So size is the number of element to be in array. So I equal to 0, I less than size I plus plus. Within that I'm going to print all my elements one by one. All my elements one by one. So for printing it, you can use printf statement percentage %d comma name of your array, in that which position you are going to index it. That thing you can define it here. So this is to print your entire array. Now after printing it, we have seen about the unsorted array element before sorting it. Now we have to sort it. So for sorting it, we are going to sort array. So we are going to implement insertion sort algorithm. So insertion sort algorithm. So I'm going to call a user event function called insertion sort. That too with two inputs. One is your input array and the size that indicates the number of elements that was in your entire array. So this is what I'm going to do. After that, I'm going to print my sorted data. Print my sorted data here. Then after that, again I'm going to call my print array function just to see whether my array got sorted. Just to see whether my array got sorted. Now we have to implement the concept of insertion sort algorithm. Again, you can go to your top where below your header files you already define your print array function. Below that, try to create another function, another user defined function called insertion sort, which accept two parameters, your input array and then number of elements in your array. Got it? Now within this thing, I'm going to write a code for it. Within this thing, I'm going to write a code for it. So we already know it. First element we always assume it in the sorting algorithm, in this insertion sort algorithm, as already in sorted one. So we will try to sort the element starting with I equal to first position, leaving the zeroth position, considering as a sorted one. I less than n, that is like I less than your size, I plus plus, and then within that you are assuming it like the current element that you have took as a key. So it's like I'm going to declare a key variable int key. The current ith position that you took is I'm going to assume it as a key. Then I'm going to compare it with the remaining list of element. So if you are at ith position, then at some jth position, your sorted array starts. So k equal to a of I, then j will be starting as j equal to I minus 1. Now we are going to find the insertions. This is the main important loop for it. So we are going to use it. So we are going to use a condition called j greater than or equal to 0. In the meantime, we are also going to check whether the element at the particular a of ith position is it greater than my key. If that is the concept, then you have to move all the elements in the sorted array one step towards its left, which means that a of j plus 1 element, you are going to a of j plus 1 element, you are going to store your a of jth element, a of jth element. Then we will be like going one step left, then again trying to check it. So j will be decremented one at a time. This will be repeated until this condition gets satisfied. Once it has been done, so we have to swap it, we have to insert the data to that particular position. This loop is to find where you have to insert your key element, which was the correct position to insert your key element in that sorted array. Right. Now what we are going to do it like a of in that particular j plus 1 position, you will be inserting your key element. This is your insertion sort algorithm. So here we will be assuming it like first element is already inserted, so we are going to sort the element from sorted from next available position. So always first element is like zeroth position. Zeroth position is already considered as a sorted one. So we will be taking the element from first position until your last element, right? So we are assuming it the current ith position element as a key, and then we will be comparing with the remaining list of and sorted elements, where in that sorted element there is a condition for looping it. So j greater than or equal to 0, and the current element that you took it, whether it is greater than, the particular key element, whether it is greater than the particular key element. So you will be using a of j, the current key element, current jth position element, whether it is greater than key. If it is true, then you have to move all the elements in the sorted array one step towards the right hand side. One step towards the right hand side. For that, we will be using a code called a of j plus 1 equal to a of j, which will try to move all your code, all your data one step towards your right. Now this is like we will be doing until j reaches 0th position. So j has to be decremented. We have it. Once this loop is getting completed, so you will be coming to a position where you have to insert your key. You will be inserting your key immediately after the jth position. So a of j plus 1 will be stored with your key value. Now we will try to run it. So enter the size of array. I'm going to give it like the size as 5. Enter the array element. Let's say that I'm going to give the element in decreasing order. 5 4 3 2 1. So this was my input. So I'm going to print it unsorted array 5 4 3 2 1, sorted array 1 2 3 4 5. So which means that your data is in sorted. It was in ascending order. It was in ascending order. Similarly, if you want to do it in descending order, then change the code. Change the code a of j less than key element. Design key element. Now we will also try to check it out whether is it descending order is also implemented successfully. Just to change the code a of j less than condition. You have to change the condition a of j less than key. So now I'm going to run it. Enter the size. I'm going to give the number of element as 6, 60, 40, 50, 20, 10, and then 30. This was my input data. Enter it. So unsorted array 60, 40, 50, 20, 10, and 30. Sorted array that was in descending order 60, 50, 40, 30, 20, and 10. Got it? Now you know how to implement insertion sort for arranging your data in ascending order as well as in descending order. Thank you. Please like it, subscribe it, and share it.